Okay, this is the second video on the inverse trig functions. The last one we did sine inverse, now we're going to do cosine inverse. I am not going to make videos for the other 4 trig functions because I doubt all of you would watch all 6 of them. If you want me to, let me know and I will. But essentially, they're in your book and I would like you to work them out on your own to kind of get an idea of what's going on using what we actually do with these. And like I said in the last video, we'll do some problems at the end of this one, and I might make another video tomorrow working through more problems to give you guys more practice. And with a little bit of practice working with all the trig functions, they'll make more sense. But we're going to do the same thing we did in the last video. We want to find arc cosine, or cosine inverse, and its graph. There's the graph of the cosine wave, and we said before we need a one-to-one function. If you look at the cosine wave, if I start here when x equals 0, I can go all the way down, all of here, and the graph never repeats itself. It passes a horizontal line test. Once I hit this point, if I start going back up, it'll fail the horizontal line test, so I don't include any of that in my domain. If I do the same thing over here, if I start going down, as soon as I go down, I'm going to fail the horizontal line test, so I have to eliminate all of that. And now as far as it goes, well, that's my cosine wave right there. I restrict my domain. What am I restricting to? For cosine x, well, my domain, this is going to start at 0. We'll say domain of f. Starts at 0 and goes to pi. What's my range? Well, it goes from -1 to 1. We said in the last video we should be able to mirror that to find the graph of cosine inverse. So let's see. If the domain of f is 0 to pi, then that means the range of f inverse should be 0 to pi. And since the range of that's -1 to 1, the domain of f inverse should be -1 to 1. Well, we could just try to sketch a graph using intuition, but maybe just to make it clearer, we'll plot some points like we did for sine inverse. So let's see, up here we'll have x and y. My domain goes from -1 to 1, so we'll say -1, 0, and 1. We won't need many to get an idea of what's going on. Do the same thing we did last time. If x is -1, what's cosine inverse of -1? What angle between 0 and pi gives me a cosine inverse, gives me a cosine value of -1? That's easy. It's pi. If x is 0, cosine inverse of 0, what angle gives me a cosine of 0? Well, that's right here, pi over 2. When x is 1, what's cosine inverse arc cosine of 1? What angle gives me a cosine of 1? 0. And now plot the points. At -1, I should get pi. At 0, I should get pi over 2, which is right in the middle. And then at +1, I should get 0. And now just connect the dots. And like I said, it may look a little bit straight, but there actually is concavity going on here where it will curve like this and then curve like that. And there's the graph of our cosine inverse. Nice and simple. Very similar to the sine inverse wave, which makes sense. I think last time we finished by saying you can also think about this from a unit circle perspective. And if we think about the unit circle, well, let's see. We are restricting ourselves to angles that go from 0 to pi. On the unit circle, angles 0 to pi are quadrant 1 and quadrant 2. Cosine's positive here and negative there. So again, essentially, as far as this cosine inverse goes, given any cosine inverse, if the x value you plug in is negative, it means you're looking for an angle over here where cosine is negative in these two quadrants. If the x is positive, well, you're in the first quadrant right here, and you're looking for the angle in there that gives that cosine. Again, I'm aware this can be a little bit tricky and kind of bizarre to work with. Ultimately, for applications, you can just throw it into your calculator and get an answer, which is fine. But we still want to be able to use our unit circle and our understanding of what's going on to kind of solve these out. So we're going to look at a few problems to really get an idea and a grasp on this. So for the sake of argument, suppose I want sine inverse of root 2 over 2. From last time, we said sine is defined in the fourth quadrant and the first quadrant on the unit circle. Which means, in other words, it's defined between angles between negative pi over 2 and pi over 2. So now, from negative pi over 2 to pi over 2, what angle gives me a sine of root 2 over 2? You all know your unit circle and your reference angles. Sine of 45 degrees is root 2 over 2. And out of the first quadrant and the fourth quadrant, sine is positive in the first. So I want the angle in the first quadrant with that sine. That's pi over 4. Suppose I want arc cosine of negative 1/2. Well, again, if we think about the unit circle, cosine is negative over here. It's the x value, so it's there or there. But cosine inverse, we just saw, was only defined here and here. So where do the two overlap? Right there, the second quadrant. So now, I just want the angle in the second quadrant that gives me a cosine of negative 1/2. All of you should know from the unit circle, the angle that gives you a cosine of negative 1/2, let's see, using the terminology I mentioned before, 1/2 is less than root 3 over 2, which means the horizontal, which is the cosine, is smaller than the vertical, which means it's really tall, which means this is a 60-degree angle. That's a little hard to see. But again, the angle I want is actually that angle right here. If that's 60, we know this is 120. So we can say 120 degrees, or if you want to write it in radians, 2 pi over 3. Those are pretty straightforward, just using the unit circle that you know. So now, to kind of make it a little more fun, suppose we compose several of these together. So suppose I have sine of sine inverse of 1/2. Now I have two different functions to work with. So let's see. Start on the inside. All of you know how this works. Sine inverse of 1/2. What angle sine inverse is in the first and fourth quadrants? What angle in those quadrants gives me a sine of 1/2? Pi over 6, 30 degrees. So then this becomes sine of pi over 6. Now apply the outside function sine. What's sine of pi over 6? Well, that's 1/2. Which is exactly what we started with. If you remember from before when you were working on inverse functions in 171, generally speaking, that will work out. These don't cancel each other out like algebraically, we can just cross them out. But to a certain extent, it works that way, but that is not always true. As an example, suppose we have sine, let's see, suppose we have sine inverse, no, we'll do it this way first. Sine of sine inverse of sine inverse of sine of 5 pi over 4. We'll do it that way to make it easy. We won't make anything crazy now. So we do the same thing. We start on the inside. Sine of 5 pi over 4. Well, 5 pi over 4, that's in the third quadrant. My reference angle, I'm deliberately not drawing these out because I want you guys to practice them and you should know them. 5 pi over 4 is down here. Reference angle is pi over 4. So the sine is root 2 over 2, but it's in the third quadrant, so it's negative. So it becomes sine inverse of negative root 2 over 2. Now find the sine inverse of that. Well, sine inverse is only defined in the first and fourth quadrants. Sine is negative in the fourth quadrant. So now we're looking for the angle in the fourth quadrant that gives me a sine inverse of negative root 2 over 2. Again, all of you know that's clearly a 45-degree angle. So I want this 45-degree angle, and we have to do it from negative pi over 2 to positive pi over 2. So it's negative pi over 4. You cannot say 7 pi over 4 because that's not within negative pi over 2 to pi over 2. And we see here that again, these don't just cancel each other out and you get 5 pi over 4. You get negative pi over 4. So it does, do not just assume, oh, I see sine inverse, I can cross that out. That's not necessarily true. We're going to do one or two more relatively quickly, and then I'll have to end this video. And like I said, if you guys have questions, let me know, and I'll make another video solving out several problems with this because I want you to practice it. Suppose I have sine of sine inverse of 2. Well, we start on the inside. What's sine of sine inverse of 2? What's sine inverse of 2? What angle gives me a sine equal to 2? Well, sine is only defined from negative 1 to 1, which means this doesn't actually work. There's no angle that will give me that sine, which means this does not exist. Because there's no angle that can do that, which means we can't solve the rest of it. This is one of those problems that teachers like to ask because students tend to just see this, cancel it out, and say the answer is 2. And no, it doesn't exist because of that. So just make sure to pay attention to that. The last one. Suppose we have sine of cosine inverse of 3/4. Well, let's see. I don't know any angles off the top of my head that gives me a cosine value of 3/4. So don't worry about it. Draw a triangle. Triangles solve a lot of things. Where is cosine inverse positive? Cosine inverse is defined in the first and second quadrant. Cosine is positive in the first quadrant. So, draw a triangle in the first quadrant. That's my theta, which is the angle I'm looking for. Cosine is 3 over 4, which means that's 3 over 4. Now, the theta I'm looking for is right there. You can throw it into your calculator and have your calculator tell you, but you don't really need it. Because all I know is this right here, I can just call theta. Now I want to find sine of theta. But I don't explicitly need to find this theta. I can use my triangle to find sine of that angle. Sine is opposite over hypotenuse. So let's see, all of you can do the Pythagorean theorem. 4 squared is 16, that's 9. 16 minus 9 is 7, so that side is root 7. Now what's sine of theta? Well, it's opposite over hypotenuse. Root 7 over 4. And you're done. And again, this is when we really get to start manipulating with our regular and our inverse trig functions. You can always solve them by just drawing triangles out. With the unit circle, you should have them memorized. If you're not sure, draw a triangle. Figure out the quadrant you're in, based off of which trig function you're looking at, or your inverse trig function. Draw a triangle. And then fill in the sides of the triangle. A lot of times, you don't even need to find the angle right there when you're composing functions like this. You can just kind of skip over it to get to the answer you care about. Hey, practice these. There's problems on Alex. There's problems in your book. Feel free to send me questions. Again, I know this tends to be a little bit confusing, so feel free to send me any questions you have, and I'll do more of this to kind of get you guys acclimated to how it works. And do the other 4 trig functions on your own. Find the graphs and the domains and ranges of the other 4 trig functions explicitly, and then solve problems with sine inverse and tangent inverse and all that other fun stuff.